Okay, so this is the key to 10.4 part G. All right, so let's see. Number one, line A is parallel to line B, and the slope of line B is 5. And then the question is, what's the slope of line A? All right, so just remember that if two lines are parallel, so remember parallel lines do not intersect. So if you look at this, if you have two lines that are parallel, they have the same tilt. So that means the slope is the same. So if this is line A and this is line B, let's say, and you're told that the slope of line B is 5, so the slope of line B is 5, then that implies that the slope of line A has to be 5 as well. All right, so remember, parallel lines have the same slope. All right, now number 2, you're told that line B is perpendicular, line A is perpendicular to line B. So remember, perpendicular lines, so let's say this is line B, and this is line A. So perpendicular lines intersect at right angles. All right, so they form 90-degree angles at the intersection. And this is line A. All right, you're told that the slope of line B is 5/7. So remember, since the slope was positive, I made this I made this right. So from left to right, the line is right. So the slope here is 5/7. All right, and then the question is, what is the slope of line A? So remember, perpendicular lines have slopes that are negative reciprocals of each other. So notice if this one's positive, this one's negative. And if this is positive 5/7, then this slope is going to be a negative 7/5. So that's the reciprocal. You take the reciprocal and you take the opposite. All right, so positive 5/7, this is negative 7/5. Okay, so negative 7/5 is the slope of line A. All right, number 3, you want to find the slope of the line that's parallel to the line that goes to these 2 points. All right, so so the first thing you got to do, if you want to, and remember, parallel lines have the same slope. So if you want to find the slope of the line, this line here, that is parallel to the line that goes to these 2 points, then you got to find the slope of the line that goes to these 2 points. So we're going to use the slope formula, x1, y1, x2, y2. So we're going to say slope equals y2 minus y1 divided by x2 minus x1. So we're going to use the slope formula. So y2 is a negative 2, subtract y1, which is 5, divided by x2, which is 0, subtract x1, which is a negative 3. All right, the numerator, that's negative 2 subtract 5 is the same thing as a negative 2 plus a negative 5. And so that is a negative 7. And the denominator, 0 subtract a negative 3 means 0 plus 3, which is 3. So the slope is, so the slope of this line here, is negative 7/3. So that means the slope of the line that's parallel to this one is also the same. So it's also going to be negative 7/3. All right. So let me just show you what this looks like in terms of the graph, just to kind of see if you understand what you just did here. So I'm going to pause this. Okay, so if we go back to number 3 and apply those 2 points here, negative 3, 5, and 0, negative 2. So negative 3, 5 is in the second quadrant. And the other point was negative, 0, negative 2. So 0, negative 2 is on the negative y-axis. And so if I draw this line, and notice that as I go from left to right, the line is decreasing. Okay, I didn't draw it very well. I did not go through this point, but it's fine. So the slope of this line we just found to be negative 7/3. So that's where we found the slope of the line to be. So the question is this. What is the slope of the line that is parallel to that one? Well, there's an infinite number of lines parallel to it. And you're not told which one of these lines that you're looking at, but it doesn't matter because all you're interested in is the slope. So regardless of, and I'm not drawing these lines parallel, but they should be, regardless of which ones I'm looking at, you need to understand that the slope of all of these lines right here, all these infinite lines that is parallel to this one that we just drew, is the same. All these have the same slope. Oops, negative 7/3, negative 7/3, negative 7/3. That's the slope of each of those lines. Okay? All right, so that's the idea behind number 3. Okay, number 4, you're told this. You want to find the slope of the line that is perpendicular this time to the points that go through these, to the line that goes through these 2 points. All right, so this time the lines are perpendicular, not parallel. Remember, parallel lines have the same slope. Perpendicular lines have slopes that are negative reciprocals of each other. So you're going to do the same approach. You're going to find the slope of that line right here. So this line right here. You're told that those 2 lines are perpendicular. So remember, perpendicular have slopes that are negative reciprocals of each other. And so now you want to find the slope of this line here. So you're really looking at 2 lines, just like you were looking at 2 lines here. So let's find the slope. We're going to call this x1, y1, x2, y2. So the slope formula, y2 minus y1 divided by x2 minus x1. So I'm going to get y2, which is 10, subtract y1, which is 3. All right, since I started with y2, I have to start with x2. X2 is a negative 1, subtract x1, which is 6. So the numerator, 10 subtract 3 is 7. In the denominator, that's negative 1 plus a negative 6, which is a negative 7. Okay, go ahead and reduce this. And you need to know that in positive divided by negative is a negative. So that's going to be negative 1. So the slope is negative 1. All right? So the slope of the line is negative 1. That means the slope of the other line here, the one that you're interested in, is the negative reciprocal. So you take the opposite, or well, the opposite of negative 1 is 1. Now, don't let this confuse you here, because 1 is going to be not the same as 2. When you take the reciprocal of 2, you can actually see the 1/2. When you take the reciprocal of 3, you can actually see, physically see 1/3, and so on. But 1, the reciprocal of 1 is 1 over 1, which is still 1. But you got to take the negative reciprocal of that. So the so basically you're going to change the sign. So this negative 1, there's going to be a positive number, and the reciprocal of 1 is still 1. So the answer is 1 here. All right, now just keep in mind that if this, just know that, I'm going to go ahead and use this page here, that if the slope here was, let's say, negative 3, all right, so instead of negative 1, let's say it was negative 3, then the slope of the line perpendicular, remember that's simple perpendicular, the slope of the line perpendicular to this one would be a positive, and the reciprocal of 3 is 1/3. Because remember, this is the same thing as saying negative 3 divided by 1. So it would be a positive 1/3. All right? But since we're looking at the slope being negative 1, the slope of the line perpendicular to this one would be, all right, since this is negative, this would be positive, and the reciprocal of 1, which is 1 over 1, is still 1. Okay? All right. So, all right. So the slope of that line is 1. Okay. Now, the next one. Oh, one other thing. When you look at the graph of this, just to remind you, when you look at the graph of this. So this is 6, 3. So that point, that ordered pair is in quadrant 1. And this is negative 1, 10. So that's in quadrant 2. Let's say that's here. All right, if I draw the line going through those 2 points. All right, so in this problem number 4, just like we did in number 3, remember these lines, these 2 lines are perpendicular to each other. So if you're told this line right here is the slope is a negative 1, then any line perpendicular to it, and there are an infinite number of lines perpendicular to this line, There's an infinite number of lines. Then each of those slopes will be the same as the others, but it'll be the negative reciprocal of this one. So the negative reciprocal, that's perpendicular here, the negative reciprocal of -1 is a positive 1 over 1, which is still 1. All right, so each of those will have the same slope. And just notice that when you look at these, all these lines here are parallel. That's why they have the same slope, but they're all perpendicular to this one. Okay? All right, so that's number 4. Number 5. All right, line A contains these 2 points, -1, -3, and 4, 6. You want to find the slope of line A. All right, so we use a slope formula. y2 minus y1 divided by x2 minus x1. And it's a good idea to label these points, x1, y1. So that's my first point. This will be my second point. I'm going to call that x sub 2, y sub 2. All right, so we're going to use a slope formula. 6, y2 is 6. Subtract y1, which is -3, divided by x2, which is 4. Subtract x1, which is -1. So again, if I start with y2, I have to start with x2. 6 subtract -3 means 6 plus 3, which is 9. 4 subtract -1 means 4 plus 1, which is 5. So the slope is 9/5. So the slope of line A is 9/5. Now the rest of this goes back to this first page. So knowing that parallel lines have the same slope and perpendicular lines have slopes that are negative reciprocals of each other. So the question is, what is the slope of the line that is parallel to line A? Well, parallel lines have the same slope, so they'll be 9/5. All right, remember, parallel lines have the same slope. Okay, now, letter C. What is the slope of the line that's perpendicular to line A? Well, it's just very similar to number 4. Perpendicular lines have slopes that are negative reciprocals of each other. All right, so this is a positive 9/5. Then the slope of the line perpendicular to it has to, so remember, negative reciprocal. So if this is positive, then that one's going to be negative, and I take the reciprocal. The reciprocal of 9/5 is 5/9. All right, line D is neither parallel nor perpendicular to line A. All right, and then what could the slope of line D be? All right, now the idea behind this one is this. So if I draw a line here, if I draw that line, let's draw this line. So that line here, the ordered pairs are -1, -3, -1, -3, -1, -3, and the other one is 4, 6. So -1, -3 is in quadrant 3, and 4, 6, the ordered pair 4, 6 is in quadrant 1. And so if I draw this line, I'm told that this slope here, we found that this slope, we just found this slope to be 9/5. So the slope of that line is 9/5. That's what we found. And so the question is, what is the slope of any other line that is not parallel or perpendicular to it? That's the question. What is the slope of line D? So we have line D. It's neither parallel nor perpendicular. So this cannot be line D. I cannot draw a parallel line, and I cannot draw a perpendicular line. But I can draw any other line going through it, as long as it's not parallel or perpendicular. So basically, I can use any slope. Any of these lines can be any slope except 9/5, because I cannot draw, line D is not parallel, so that cannot be 9/5, and line D is not perpendicular, so it cannot be -5/9. So that I can put any other number I want to. So there's an infinite number of choices here. So you could say, well, -2/3 could be the slope. negative 6/7 could be the slope. The slope could be 0, which would make it a horizontal line. Slope could be a positive 6. Slope could be a negative 7. Slope could be positive 6/5, and so on. So there's an infinite number of points, infinite number of slopes you could give me, as long as you can't use 9/5 because you're told that you don't want it to be parallel, and you can't use negative 5/9 because you're told you don't want it to be perpendicular. Okay, so any other real number will suffice. All right, that takes care of the key to worksheet 10.4, part G.